Hi, Allan Row, welcome to my home, Project Manager with British Gas. Just here today to give you a quick tour and to show you some of the appliances and communications kit we have in the house for the Customer-Led Network Revolution trial. In front of me here what we have is the hub, which is the communications hub, which is connected to my home broadband router and sends all the data being collected around the house back over the internet to the backend server, collecting data on appliances around the house, and also some of the loads around the house as well, like electricity circuits, sockets, lighting and so forth. We also have here the British Gas Nano Hub, as it's called, which is part of the Hive active heating system, whereby remotely and through an app on my phone I can control the temperature within my house just by literally scrolling through and either taking it up or taking it down. Also here what we have is the smart meter in-home display, which displays all the energy being used in the house. It displays it real time in pounds, kilowatt hours and CO2. The light changes instantaneously, about a 5-second delay actually, when you turn on the kettle, denoting that you're using more electricity. So you get that kind of instantaneous real-time feedback coming through. You can also delve into the history, some of the profile history of how you've been using electricity over the past 24 hours, or the past few days, or indeed over the last week or month, basically enabling you to build up some kind of comparison for yourself and maybe even set yourself targets as to how you're using electricity in your home, enabling you to get closer to your energy use. So that's just a quick view of all the connected hubs in the house and displays. Now going to move on and show you some other appliances and monitoring around the house. So continuing the tour, here we have a micro combined heat and power boiler. It's a Baxi Ecogen boiler. Effectively what this does is, as it's generating heat and warming the water for the heating and hot water system, it's generating electricity at the same time. So it is another form of microgeneration which we're monitoring on the trial. You can get the feed-in tariff payment for it, and we're monitoring it through some secondary metering within the house. Another trial which we're running on CLNR is the smart washing machine, smart appliance trials. For all intents and purposes it is a standard washing machine. The smart functionality part comes into play where you've got the antenna symbol there denoting that it's connected to the internet via the communications hub. On these trials we have two trial variants. We're looking at first and foremost a tariff-based one, a time of use tariff-based trial, whereby there's a disincentive for using it in peak. The machine effectively knows what tariff that you are on as that household, and automatically schedules a wash for the cheapest time according to your tariff, which in this case is after 8 o'clock in the evening. Trial variant that I've got here today, which we're demonstrating, is the latter home energy control supply manager, whereby we're able to send interruption signals to the machine requesting that the machine doesn't run due to some certain network constraint or fault. So if we were to run an example of that, a message will be displayed which encourages the customer to first and foremost put it into the smart enabled mode. So we get this message here, the customer comes along, presses the energy control button, you get a short message to say yes, that's enabled, and it continues to say that the energy supply manager will be activated from a period of time to an end period. Effectively we're messaging customers and saying there's a network fault, could you please not use the washing machine. So a customer will come up to the appliance in this mode and will try to run a schedule or select a program. I've selected the appropriate program, I'm going to press start, and it will wait to start after that event has passed. Okay, so as already shown in the house, there are a number of trials that we're running. Effectively this area is where a lot of that gets hardwired into the circuits of the house. Before I go on to talk about that, we've got the Cool Power EMA unit, which is a within-premise balancing system. What that means is that it takes the excess generation from the solar panels that isn't being used and therefore potentially exported, and it turns on the electric element within the hot water cylinder upstairs in the airing cupboard. So what it's doing is it's monitoring the output of the solar panel system, it's monitoring the demand of the house, and if the output is greater than the demand, it effectively turns on the immersion element upstairs, thereby making greater use, in-home use, at the time of it being generated rather than it being exported to the grid, which is something that we're trying to mitigate because that does cause issues for the grid in terms of voltage limitations and two-way power flow. Moving on, we have here what we call the polymeter, which is monitoring all of the circuit loads within the house. So here we have the consumer unit, aka the fuse board. In here it's got current clamps, which is monitoring the upstairs downstairs lights, sockets, power shower, cooker, etc. So we have the smart meter behind this box and to the outside of the wall. The smart meter gives us that whole house view of how energy is used in the home, and under the trial that we're running, which is called in-home monitoring trial, we're looking at disaggregating that view, looking at all those various loads and some appliances with smart plugs in the house to build up that disaggregated view, which ultimately marries up to the whole house view that we're getting from a smart meter. And that will give us a better understanding of how people use their energy in their homes, with what appliances, what loads, what time of day, etc. Moving on, we have the power quality unit. This is effectively monitoring the power quality of the house and the solar systems on the roof. What it effectively does is look at the power quality effects that the solar panel inverter has when it's changing it from DC to AC, so that we can again understand, with people, multitudes of people having these various types of technologies, low carbon technologies such as I already mentioned solar panels, but also electric vehicle charge points, air source heat pumps, etc. We can start to understand what their power quality effects might be, and therefore better understand when we start to ramp them up and they become more commonplace, what that might mean to the network. So that's my house. We've looked at the low carbon technologies that we've got, such as the solar panels, the smart appliance. Also looked at the various loads and etc. that we're monitoring around the house and how that's connected. Under the CLNR project, we're running a host of trials looking to understand customer load and generation and power quality characteristics and their impact on the local electricity distribution network. We're also looking to see how flexible customers might be if we would put on certain tariffs, time of use tariffs, or indeed send them some direct control messages so they're able to change their behaviour at all. So we're now at a stage in the project where we're starting to collect a lot of the data, and that's going into our analytical phase of the project. We are seeing quite a good pot of statistics where we're able to look to answer all the questions that we set ourselves on the project, and by doing so we hope to see that we will be able to mitigate some of the need to reinforce networks and accelerate the uptake of low carbon technologies as we go forward and these things become more and more commonplace.